Alright guys, so what we're doing today is going over the review sheet, and we're going to go over some of these problems. I'm going to go through all of them here, and I'm going to post this later. So if you're watching this, you're going to be looking back at it. Now, for problems 1 through 5, I'm going to look at 2 of them. I'm going to look at these first 2 because these are all for bonus points. They're not actually on the test. And to get the bonus point, because it's only worth 1 point apiece, you need to get all of the transformations. Now looking at the first one here, we have 3 transformations. The 3 on the outside, this plus 3 tells us it's going to move the function up or down. In this case, the plus 3 is telling us it's moving up 3. The minus 1 inside the function tells us left or right, and it's the opposite of what we think. So it's actually right 1. And the last one, the number multiplied in front, if it's positive, in this case it is 1/2, tells us it's a vertical stretch of, shrink of 1/2. Because if it had been greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink. And that's all for that one there. Now if we look at number 2, again we have 3 transformations. The 4, the plus 3, and the plus 1. Now the plus 1 tells us it's up or down. And since it's positive, it's going to move up 1. If it had been minus 1, it would have been down 1. The plus 3 on the inside tells us it's a left or right transformation. Opposite of what we think would be left 3. And the 4 on the outside tells us this is a vertical. In this case, it would be a stretch of 4. Now, if the number in the 4 spot had been negative, it would have been a reflection across the x-axis, and a negative in front of the x inside the parentheses, a reflection across the y. And if we have a number in front of the x inside the parentheses, it's a horizontal stretch or shrink. We have to flip it, and it's the opposite of what we think. Now that brings us to these here. Now there is a reference guide for these here in the back of your note sheet, and 6 and 7 are set up in Vertex Form. This here, where the vertex for Vertex Form is the point h comma k. So our h value is right here, k value is on the outside. So it tells us the k value is 5. H value, since we have minus 2 coming out of the parentheses, would make it positive 2. And the axis of symmetry for this here is x equals h. I've already found the value of h is 2. So the axis of symmetry we're looking for is x equals 2. And the vertex is the point 2, 5. Now the same thing is true in number 7. It's in vertex form. Now the main way you can tell the difference between vertex form and standard form is 1, vertex form has our parentheses squared plus k, and we have it set up. It looks like this here. And again, the vertex is the point h comma k. Well, our k value is what's added on the outside. Since there's not 1, it's 0. We have plus 1 inside. It's going to come out at the opposite, so it would be minus 1. And the other part is our axis of symmetry, which is our x equals h. Our h value is negative 1. So that's all we have for those 2 there. 8 and 9. Both of these are in standard form, which is our matching our ax squared plus bx plus c. A is the number in front of x squared, b is the number in front of x, and c is our last number. A, b, and c, none of these will have a variable attached with them. And again, if we reference back to our forms for standard form, the vertex is the point negative b over 2a comma f of negative b over 2a. So the first thing we need to evaluate for this here is negative b over 2a. And looking at this here, the value of b is 2. A, there is a number in front, and it is 1. So we get negative 2 over 2 times 1. Now we can grab the calculator, fraction negative 2 over 2 parentheses 1. Hit enter. It'll calculate it for us and tell us it is -1. Now to find our f of negative b over 2a, all that's saying is take -1 and plug it back into the function. So everywhere there's an x, we're replacing it with -1. Now we can do this by hand, or we could do it in the calculator. Parentheses -1 squared plus 2 parentheses -1 and -1 gives us -2. So this is equal to -2. So our vertex is the point -1, -2. Now the axis of symmetry, x equals, well, x is equal to -b over 2a. Well, we already found it as -1, so we get this here. Now we have our next one here. Now again, this is standard form, but we're just matching it up. Which one does it match up to? And that's standard form. And again, the vertex is the point -b over 2a, comma, f of -b over 2a. So again, we need to evaluate -b over 2a. Our b value in this case would be -8. And our a value in this case is -2. Now if you wanted to type it in instead of -8 as just 8, that's fine. Or you can type it in exactly as it is and give us the value of -2. So the x value of the vertex is -2. Incidentally, the axis of symmetry, x is equal to -b over 2a. So the axis of symmetry is x equals -2. We already have that point. Now to find our f of -b over 2a is just plugging it back in. So we'd have -2 times -2 squared minus 8 times -2 plus 1. And again, we could do this by hand, or we can plug it all into the calculator. Plus 1, enter, is 9. So our vertex is the point -2, 9. Our axis of symmetry is x equals -2. And the last one here is in vertex form. And the vertex is the point h, comma, k. Again, there's nothing added on the outside, so the value of k is 0. Our plus 1 on the inside matches up with our h, telling us it is -1. And our axis of symmetry is the equation x equals h. And as we already said, h is -1. We have everything we need here. Vertex, focus, directrix, and axis of symmetry. Now for these here, it's not telling us what the vertex is, or else it's not asking for the vertex. But even so, we still need to find the value of h, k, and p. Now since it's y equals, this is matching up with our y equals 1 over 4p times x minus h squared plus k. Now since there's no parentheses and nothing added to it, it means h and k are 0. Because we don't have something added to x inside parentheses or added to the n, so h and k are 0. Now to find the value of p, well, p is equal to 1 over 4 times whatever's in front of the parentheses, which in this case is -112. Now at this point, we could plug it into the calculator and let it do it for us. And it's going to tell us it is -3. So the value of p in this case is -3. Now it wants us to find the focus. Now since it is y equals, our focus is the point h, comma, k plus p. We already know h is 0. But we do need to evaluate k plus p. K is 0, p is negative 3. So the y value of the focus is negative 3. Our directrix is the equation y equals k minus p. So we can calculate it, k minus p, plug in the values of h and, or k and p, negative, negative make a plus, giving us plus 3. So we have directrix, focus, and the last piece is axis of symmetry, which in our case is x is equal to h. H value is 0, and that's all we're looking for here. 12, x equals. So I'm going to match it up with its general form. And again, we're still looking for the values of h, k, and p. No parentheses, so nothing's added to or subtracted from y inside, so k is 0. Nothing's added to it on the end, so h is 0. And leaves us with finding the value of p. So it's 1 over 4 times whatever's in front of our square. So we have 1 over 4 times 1/24, which is 6. So the value of p is 6. Now at this point here, we can find the focus. Now it's x equals, well, the focus in general form is h plus p comma k. Well, our k value is 0. H plus p we need to calculate. Well, that's going to be 0 plus 6, which is, well, 6. Directrix. X equals, well, in the general form, it's x equals h minus p. So we need to calculate h minus p, which would be 0 minus 6. Telling us the equation is x equals negative 6. Our axis of symmetry. Well, in the general form, it's y equals k. So in this case, it's y equals 0. And those are the 3 pieces of information we need. Really, we can just say box it instead of circling each one. 13. All right, so this is the problem that's in your note sheet. It looks a little different than I had it originally, but this is the one that y'all are working with. Now, because it's y equals, the general form is y equals 1 over 4p times x minus h squared plus k. And again, we need to find the values of h, k, and p. Don't have anything added inside the parentheses, so h is 0. Nothing added on the outside, so k is 0. Now we do need to find the value of p, which is 1 over 4 times whatever's in front of the parentheses. So 1 over 4 times negative 148 over 48 gives us negative 12. Now we need to find the focus first. And since we are talking y equals, our focus is the point h comma k plus p. Now we can calculate k plus p. K is 0, p is negative 12. So it tells us k plus p is negative 12, and h is 0. Directrix. Y equals, well, in the general form, it's k minus p. So now we can calculate k minus p, which would be 0 minus negative 12, giving us positive 12. And lastly, axis of symmetry, x equals, in the general form, it's x equals h. Well, h in our case is 0, and that's all we have to do for this here. Now this next one here, y equals x squared. Well, It's a little bit flipped, but it's still our y equals 1 over 4p times x minus h squared plus k. And we need to find the values of h, k, and p. Nothing added inside the parentheses with x, so h is 0. Nothing added to the end, so k is 0. But we do need to find the value of p, which will be 1 over 4 times our term that's being squared. In this case, it's 8. And if we did plug this into the calculator, we would get 1/32. So the first thing we can find is the focus. And since it is y equals, we still have the point h comma k plus p. Well, our h value is 0. And if we evaluate k plus p, it'd be 0 plus 1/32, which is just 1/32. Our directrix will be y equals, well, k minus p, 0 minus 1/32, which is negative 1/32. And our axis of symmetry, x equals h, in that case it's 0, and we get this here. Lastly, of this type is this here. We get this here. We need to find the value of h, k, and p. Nothing added inside the parentheses, so h is 0. Nothing added onto the end, so k is 0. And our p value is equal to 1 over 4 times the number in front of our squared term, 1/4. We plug that in, we would get 1. Now our focus, again, is the point h comma k plus p. H is 0. K plus p would be 0 plus 1, which incidentally is 1. Now the general form for the directrix is k minus p. Our k minus p would be 0 minus 1, which would be negative 1. And our axis of symmetry, x equals h in the general form. Well, h is 0, and we get this here. For problems 16 through 19, with these here, now for this one, the vertex is the point 0, 0. So to find these, we need the values of h, k, and p. Well, the vertex is the point 0, 0, and vertex in the standard form is the point h comma k. So it tells us h is 0, k is 0. And again, to determine which equation we have, we're going to be looking at what's given to us. The biggest indicator for this one here is the directrix is y equals. And there's only one equation that has a directrix of y equals, and that's our y equals 1 over 4p times x minus h squared plus k. Now the directrix tells us our k minus p is taking the place of 2, or that k minus p is 2. We know k is 0, and we plug in what we know, which really leaves us with p, or that negative p is equal to 2. We can multiply or divide both sides by negative 1, telling us the value of p is negative 2. At this point here, we can plug it all back into the equation, telling us y is equal to 1 over 4 times negative 2 times x minus 0 squared plus 0. Now we can simplify our 1 over 4 times negative 2, which will simplify to negative 1/8. Our x minus 0 squared simplifies just to x squared, and we don't need the plus 0. And that's it. Now the vertex is the point 0, 0. You will be given that on every problem, what the vertex is. You won't be given one that you're asked for the directrix and focus for this one here. So vertex is h comma k. And again, we still need to find h, k, and P. Now, the vertex will not be 0, 0 for every problem of this kind of type, but it will for you for this one here. Now, that tells us H and K are both 0, leaving us to find the value of P. Now, we do have the directrix as y equals. In this case, it is K minus P. But of that similar type, the focus is the point H comma K plus P. And this one, I'll do the focus, because it's telling us that K plus P, when we plug in the value of K and P, we'll get a value of -7. Well, we know the value of K is 0. So 0 plus P is -7, which is just telling us P is -7. Now, because the directrix is y equals, we have this set up here, so we're looking at y equals 1 over 4p. Now our value P is -7, H is 0, K is 0. Now again, at this point, you could plug in 1 over 4 times -7 into the calculator. It'll give us -128. Since it's x minus 0, that simplifies down to just x squared, and we get this here. All right, now we're looking at problem number 18. Now this one gives us the vertex and the focus. And again, to find the equation, we need to find the value of H, K, and P. Well, the vertex is our point H comma K. So it's telling us the value of H and K are 0. Now, we need to find the value of P and we need to find the general equation. And to find that, we need to see what changes from the vertex to the focus. Well, we can see that the K value is 0 here. It's still 0 here, which means we just have K. The H value is the one that changed. We added something to it. So that's going to be our H plus P. And if we compare it to the general form, the one that has a focus of H plus P comma K is our X equals 1 over 4P times Y minus K squared plus H. Now we just need to find the value P. Now the focus also told us that H plus P was -10. Our value of H is 0, so 0 plus P is -10, or P is just -10. So X is equal to 1 over 4 times -10 times Y minus 0 squared plus 0. And if we simplify this here, we can plug our 1 over 4 times -10 into the calculator, which will give us -1/40. Our Y minus 0 squared simplifies to Y squared, and we get this here. The last one of this type is this one here. Our vertex is the point H comma K. And the directrix x equals, well, there's only one of the equation with a directrix of x equals, and it's actually given to us by the equation x equals H minus P. It also tells us that we're looking at the equation x equals 1 over 4P times Y minus K squared plus H. The vertex, H comma K, tells us the value of H and K are 0 and 0. The directrix tells us that when we plug the values of H and P into the equation, it should simplify to -9. Now we're told that H is 0 from the vertex, so we have 0 minus P equals -9, or that -P is equal to -9. Now we can multiply or divide by -1 to simplify P from -P to +P, and that tells us the value of P is 9. Now at this point here, we can plug it all back in. 0 and 0 in for H and K, and 9 in for the value of P, which tells us that X is equal to 1/36 Y squared, because our Y minus 0 squared simplifies to just Y squared, and we get this here. 20 through 23, these we want to find the vertex, focus, axis of symmetry, and directrix. And again, we need to find the values of H, K, and P. So we have y equals 1 over 4p times x minus h squared plus k. Our h value comes from inside the parentheses. Since we have minus 3, the value of h is positive 3. K is our outside, so plus 2 tells us the k value is 2. And to find the value of p, well, it's going to be 1 over 4 times the number in front of our term being squared. In that case, it's going to be 1/8. 1/8. Now, at this point here, we can plug it into a calculator. 1 over 4 parentheses 1/8. Enter is 2. So it tells us the value of p is 2. Now we're going to find the vertex, focus, directrix, and axis of symmetry. Now our vertex is the point h comma k. Well, the h value is 3, the k value is 2, so our point is 3, 2. Our focus in the general form with y equals is h comma k plus p. Well, we do have the h value. It's 3. Now we do need to calculate k plus p. So our k value in this case is 2. Our p value is 2. And 2 plus 2 gives us 4. Directrix is x equals h minus p. In this case, it would be 2 minus 2, which is 0. So the directrix is x equals 0. Axis of symmetry is represented by the equation y equals k. K value is 2. Nope, sorry. That's off. Because the directrix should be y equals k minus h, k minus p gives us this here. And the axis of symmetry for this here should be x equals h. X equals 3. That's the correct one. Now again, that's another reason I would say make sure to look back and continue to reference the general forms, because it is easy to get these mixed up. Incidentally, I did plug in the right values for k and p instead of h and p, but we do get a directrix of y equals 0, and the axis of symmetry should be x equals 3. So do pay attention to make sure you put it in the correct form. Now 21, we want to find the value of h, k, and p. H is on the outside this time, so it's -1. Our plus 5 inside represents our k value of -5. And our p value is going to be 1 over 4 times the number in front of the term being squared, which in this case would be 4. Telling us that the value of p is 1/16. Vertex is still the point h comma k. Well, our h value in this case is -1. K value is -5. Focus. And the focus for x equals is our h plus p, comma, k. So our k value is -5. H plus p, in this case, would be -1 plus 1/16. Now we can do this in a calculator. -1 plus 1/16 is -15/16. So the x value of the focus is -15/16. Now our directrix this time is indeed x equals, because the general form is x equals h minus p. So this time we'll have -1 minus 1/16. Is -17/16. And the axis of symmetry this time is indeed our y equals k. So this would be y equals -5. And that's it. 22. So we still have another x equals, so x equals 1 over 4p times y minus k squared plus h. So we need to find the value of h, k, and p. H is on the outside, matches up with our plus 2, so it's positive 2. Our plus 4 inside matches up with our k. Because it's positive 4 inside, it comes out as -4 to match up with that sign change. And our p value is equal to 1 over 4 times the number in front of the parentheses, which is -3, which actually gives us a p value of -1/12. And we're just using these equations here. Now to find the vertex, focus, directrix, and axis of symmetry. Vertex is still our point h, comma, k. Our h value is 2. Our k value is -4. Our focus, again, we have x equals, and if we look at the form, it's h plus p, comma, k. So our k value is still -4. H plus p would be 2 plus -1/12. Will actually work out to be 23/12. Our directrix is going to be x equals, in the general form, it's x equals h minus p, which would be 2 minus -1/12, which actually works out to be 25/12. And again, you could type that into the calculator. 2 minus -1/12 is 25/12. And lastly, axis of symmetry. So that's y equals k, so y equals -4. And that's it. 23, the last one of this type. So it starts off with y equals, so we have y equals 1 over 4p times x minus h squared plus k. Now we need the values of h, k, and p. K is on the outside, so in this case it is 1. H is on the inside, -3 comes out as +3. And our p is equal to 1 over 4 times 1/16. And if we type that in, we get 4. So the value of p in this case is 4. Now the vertex is the point h, comma, k. Well, our h value in this case is 3, k is 1. Now our focus for this here is the point h, comma, k plus p. Well, our h value stays the same, 3. We do need to calculate the k plus p, which in our case would be 1 plus 4, giving us 5. So the focus is the point 3, 5. Directrix is going to be our y equals k minus p, which would be 1 minus 4, which is -3. And lastly, axis of symmetry, x equals. In the general form, it's x equals h. So in our case, x equals 3. And that's it. 24, find the equation from the given information. Well, we still need the values of h, k, and p. Pretty much everything revolves around these here. Now the vertex is going to be the point h, comma, k. So that tells us h is 7, k is 3, but we still need to find the value of p in the equation. Now if we're given the vertex in focus, we need to see which one changes. Which one do we add p to? Do we add it to h or k? Now since the vertex y values are 3 and 3, k doesn't change. We didn't add anything to it. But the h value went from 7 to 14. We added something to it. So we're saying that the focus in the general form is h plus p comma k, which means our equation is going to come in the form of x equals 1 over 4p times y minus k squared plus h. It also told us that h plus p is equal to 14. Now, unlike the other ones, h is not 0. In this case, it's 7. And we do need to solve for p by subtracting 7 from both sides. And it tells us p is 7. Now, at this point here, we can plug in the values of p, h, and k. Do make sure to plug them in the correct locations. Now, when we simplify 1 over 4 times 7, we get 1/28 times y minus 3 squared plus 7. And we get this here. And that is the final equation, because once we get the values of h, k, and p, we plug them back in. Vertex, hk. So we do need to find the value of h, k, and p. And already from the get-go, we know that h is 4 and k is 1. Now we need to see which one changed. Well, we can see that the y value is 1 and 1. So the value of k did not change from the vertex to the focus. We didn't add anything to it. But our other value went from 4 to 6. So we added something to our first spot. So this is similar to the last one. So we have 1 over 4 times p times y minus k squared plus h. It also told us that h plus p is equal to 6. Well, our value of h is 4. We can subtract 4 from both sides to get p by itself. And it tells us the value of p is 2. Now at this point here, we can plug k, h, and p back in. And we simplify 1 over 4 times 2, we get 1/8 times y minus 1 squared plus 4. And that's it. Now, if we look at this next one here, we still need to find the value of h, k, and p. Now, the vertex is the point h, comma, k. The focus, we do need to figure that out. Well, we can see that the first spot, -6, is the same in both. So that means the first spot is still h, which tells us that the other one has to be k plus p. Now, that tells us two things. One, that the general form is going to be the equation y equals 1 over 4p times x minus h squared plus k. We also know that h and k, h is -6, k is -4. And it also told us that k plus p is -10. Now we can solve for the value of p, because k is -4. Plus p equals -10. At this point here, we can add 4 to both sides, telling us that p is -6. Now at this point here, we can plug everything back in, making sure to plug in the correct spots, values for h and k. And this will tell us y equals, well, we can plug that in. 1 over 4 parentheses -6, -1/24. Our x minus -6 is the same as x plus 6 squared. And our plus -4 is the same as -4. And that's it for that one there. And if you're wondering, there is no 26. That brings us to 28 through 33. Find the equation from the given information. Now, these are a little bit different in that they gave us the vertex and a point that passes through it. So this is our vertex form. Now the vertex is our h comma k. So that gives us the first part of this equation, because it tells us the h value is -6 plus our -12. Well, the negative makes a plus, and our plus -12 is just, well, we can say -12. So we found 2/3 of the equation. The last thing we need to find is the value of a, and that's where our point comes into play, because it's our x comma y. And what it's saying is that when the y value is -24, our x value should be 0. So if I plug in 0 for x and -24 for y, we can solve for the value of a. Now the first thing we'll need to do is simplify what's inside the parentheses. So 0 plus 6 gives us 6. Now a times 6 squared, well 6 squared is 36, times a is 36a. Now we do need to get a by itself. So the first thing we can do is add 12 to both sides, telling us that 36a is equal to -12. And last but not least, we can divide both sides by 36, telling us a is -12 divided by 36 is -1/3. And last but not least, we can plug that back in for a. So we get y equals -1/3 times x plus 6 squared minus 12. Now the next one, they give us a vertex and the point it passes through. So we're still using vertex form. Y equals a times x minus h squared plus k. Now the vertex gives us the point h comma k. So y equals a times x minus -1 squared plus 14. Well, our negative makes a plus. Now again, just like with the last one, we'll plug 35 in for y. We'll plug 6 in for x and solve for the value of a. So the first thing I'll do is 6 plus 1. Simplify what's inside the parentheses. 7 squared is 49 times a is 49a. Now at this point here, we can subtract 14 from both sides, telling us 49a is equal to 21. Now at this point here, we can divide both sides by 49, telling us a is 3/7. So y is equal to 3/7 times x plus 1 squared plus 14. And that's it for that one there. 30. This one's a little bit different because it didn't give us the vertex, it gave us the x-intercepts. So we'll have to use our x-intercept form. A times x minus p times x minus q. Now x-intercepts come in one of two forms. They'll either tell us what the values of the x-intercepts are, -16 and -2, which is just telling us the value of p is -16 and the value of q is -2. And our negative make plus and plus, or they can tell us it's the point -16, 0 and -2, 0. We know those are x-intercepts because the y values are 0. Now just like the last one, to find the value of a, we're going to plug the point -1872 in for the x and y corresponding spots. So we'll plug 72 in for y and 18 in every place there's an x. Now the first thing we can do is simplify what's inside the parentheses. -18 plus 16 is -2. -18 plus 2 is -16. -2 times -16 is positive 32a. At this point here, we can divide both sides by 32. 72 over 32 is 9/4. So that tells us the equation is y equals 9/4 times x plus 16 times x plus 2. 31, they gave us the x-intercepts. So our general form is y equals x minus p times x minus q. P and q are really interchangeable because they're just the x-intercepts. And for us here, we'd say x minus negative 7 times x minus negative 3. And in both cases, our negative and negative would make a plus. And to solve for the value of a, we'll place y with 0.05 and our x's with negative 2. Now we're going to simplify what's inside our parentheses. Negative 2 plus 7 is 5. Negative 2 plus 3 is 1. 5 times 1 times a is 5a. Now at this point here, we can divide both sides by 5 and get 0.01. So y is equal to 0.01 times x plus 7 times x plus 3. We could have also written it as y equals 1 over 100 times x plus 7 times x plus 3. Both of these work. This one here, we're given the vertex in a point that it passes through. So we're going to use vertex form. Vertex is the point h comma k. So it gives us 2/3 of what we need. So we have x minus 3 squared plus 1. And just like the previous ones, we're going to plug 5/9 in for y, 1 in for x, and solve this here. So I'll simplify what's inside the parentheses first. 1 minus 3 is negative 2 squared plus 1. Now our negative 2 squared, negative 2 times negative 2 gives us positive 4a. Now at this point here, we can subtract 1 from both sides, which will tell us that 4a is equal to negative 4/9. Because we can plug that in a calculator. 5/9 minus 1 is negative 4/9. And last but not least, we're going to divide both sides by 4. Divided by 4, negative 1/9. And that's it for that one there. For problems 28 through 33, find the equation. Well, it gave us the x-intercepts. So we have y equals a times x minus p times x minus q. And for us here, our p and q are 0 and 4. And again, just like with the previous one, we can plug our 2.25 in for y, 3 in for both x's, and solve for this here. So 2.25. A times, well, 3 minus 0 is 3. 3 minus 4 is negative 1. Well, 3 times negative 1 times a is negative 3a. At this point here, we can divide both sides by 3. 2.25 divided by 3 is 0.75. And it would be negative 0.75, so y equals negative 0.75. Well, our x minus 0, we can leave it as x minus 0, x plus 0, x minus 4. Yep. Or we can say y equals negative 3/4 times x minus 0 times x minus 4. And that's it for that there. 34 through 37, find the x-intercepts, axis, symmetry, and vertex. Well, the x-intercepts is 2 points, and the y values of the x-intercepts are always going to be 0. And in the general form, x minus p times x minus q. So our p is lining up with our negative 7 minus 7, which would just be 7 when it comes out of the parentheses. Our q in this case is lining up with our plus 3, which will come out as negative 3. Now the vertex in the general form is p plus q over 2, comma f of p plus q over 2. So for us here, we do need to evaluate what p plus q over 2 is. Well, p and q are 7 and negative 3. Now we can do this by hand and give us 2, or we could plug it in the calculator also. Now the last bit is the f of p plus q over 2. All that's saying is we take the formula and plug in 2 everywhere there is an x, and then simplify. Which should simplify down to 25/4. That should be negative or negative 6.25. And our axis of symmetry is x equals p plus q over 2. Well, we already found that value, and it is 2. That's all we have to do for these here. Now again, this is another x-intercept problem. And one of the first things we need to find are the x-intercepts. Now our p lines up with our plus 9, so it comes out as negative 9. Our q lines up with our plus 3, comes out as negative 3. Now our vertex is going to be our p plus q over 2. P is negative 9, q is negative 3. And again, we could do this by hand, or we could plug it into the calculator, and we get that negative 6. Now the other part of this is to plug it back into the formula. So we'd have negative 2, parentheses, negative 6 plus 9, times negative 6 plus 3. So it'd be negative 2 times 3 times negative 3, which would be negative 2 times 3 is negative 6, times negative 3 is 18. And our axis of symmetry is x equals our p plus q over 2, which would be negative 6. And that's it for that one there. Now that brings us to the last two. So we have this here still in x-intercept form. So our x-intercepts. Y values are 0 in both places. One of the x-intercepts values is going to be negative 9/7. The others is 3/4. Vertex and axis of symmetry. Well, the x value of the vertex and our value that goes into the axis of symmetry are both attained by our p plus q over 2. So that'd be negative 7/9 plus 3/4 all over 2. And I would definitely plug that into a calculator. Negative 7/9 plus 3/4 all over 2 is negative 1/72. And we can plug that back in. So we have negative 1/72 plus 7/9 times negative 1/72 minus 3/4 parentheses negative 1/72 plus 7/9 parentheses negative 1/72 minus 3/4 is this here. We'll go out 4 decimal places, 0.5835. We could try to convert it back to a fraction, see if the calculator will do it, and it says no. And that brings us to the last problem. Still x-intercept form. So the first thing we need to find is our x-intercepts, which is our p comma 0 and q comma 0, which would give us 3 and -8. Now our vertex is the point p plus q over 2, comma f of p plus q over 2. So our p and q are 3 and -8. 3 plus -8 over 2 is -5/2. So it tells us the x value of the vertex is -5/2. And actually our axis of symmetry is x equals p plus q over 2. And it's also -5/2. And the last thing we have to do is plug it back in to find the y value of the vertex. -7/9 times -5/2 minus 3 times -5/2 plus 8 is 847 over 36. Even if we get not as nice answers, that's fine. But that is it there. And that is the end of the review sheet.